Hello, I welcome you all in this lab class related with the subject surface engineering. And in this class particularly, I'll be talking about how to perform the slurry erosion test. You know that in surface engineering we develop the modified surfaces or engineered surfaces for the different applications. Depending upon the requirement, we make it very hard and abrasive wear resistant, or very hard and tough surfaces for erosion resistant, very hard surfaces for say adhesive wear resistant. So we need to ensure that what is the degree of the modification, what is the kind of improvement which has taken place after the modification with respect to the substrate properties on its own. So it is important to see like how can we check the uh, erosion resistance of a surface or of a substrate, so that we can assess the degree of improvement or the kind of improvement after the surface modification has taken place. So, the slurry erosion test can be performed in number of ways. One of the simplest way is that we create a slurry in a tank, and then the sample is rotated at a particular speed, so that the slurry particles, the hard particles present in the slurry, they strike the surface and they cause the erosion. But in that case, there is no control over the speed at which these particles are impacting, or the angle at which the particles present in the slurry, eroding particles in the slurry, that they are impacting. So, a better way of slurry erosion test has also been devised over the years, and that is called slurry jet erosion test. So, in that case, we prepare a slurry of the suitable material. Slurry means it is having say some suitable solution, which is mostly in form of the water or the sand particles, or it can be anything else against which the slurry erosion resistance or slurry erosion test is to be conducted. So here in this case, this is a big tank which is having the slurry of the water and the sand particles. So sand particles of the different sizes in different proportions, they are mixed and dissolved. So we continue to stir the slurry so that the composition or there is uniformity in the distribution of the eroding particles in the slurry, and this slurry is then pumped and forced to pass through the jet. So here there is a motor which will be circulating the slurry through these pipings, and then the slurry is forced to pass through the nozzle. So when the slurry is passed through the nozzle at a high pressure, we get certainly the higher velocity of the jet which is coming out. So the jet will be coming out of this nozzle, and here we mount the specimen whose slurry erosion resistance or slurry erosion behavior is to be checked. So basically there is a jet which is coming out at identified speed, and it is directed over the surface whose resistance is to be checked. So depending upon the kind of the type of the eroding particles which are present in the slurry, there is size, their hardness, the erosion from the surface will be taking place at the different rates. So basically against a particular medium, the slurry erosion behavior of the surface is checked. It can be substrate or it can be any modified surface. So here now we will basically there is another thing as far as the parameters are concerned for this kind of the test is like there can be different concentration of the eroding particles in the slurry. There can be the different types of the slurry, different types of the eroding particles in the slurry, and there can be different you can see the velocities at which the jet can be directed over the surface. Jet can also be directed over the surface at different angle. So here we can have one fixture, so over which we can mount the substrate, and then jet can be directed over the surface at different angles. So it can be 90 degree, it can be 30 degree, it can be 60 degree, like that. So basically we try to ensure that jet is directed over the surface whose erosion resistance is being checked, and it is directed at a particular angle. So that is what kind of arrangement can be made here, or arrangement is made. So here particularly at this stage we are directing the jet at 90 degree, but it can also be directed at 45 degree, 30 degree or 60 degree as per the need. Now we will be showing that how the slurry erosion test is carried out. Since in this case slurry is little, it is a fluid, we will show you the slurry also. So when it is circulated, a jet at very high velocity will be coming out from the nozzle, and then it will be directed over the surface. So we have to close this, so we cannot see basically how the test is actually happening, but this is the kind of setup which is used, and we will show that we will try to show how the jet comes out and then the test is performed. Thank you. Now you can see that with the help of stirrers, two stirrers, the stirring of the slurry is being done, so that the composition and the decomposition of the slurry is almost uniform, and the distribution of the erodic particles is also uniform. And this slurry now will be pumped when we start the jet, it will be pumped through the piping system, and then it will be passed through the jet to direct it over the surface of the samples. Now you see we are directing the jet over the sample, and a lot of slurry is coming out from the jet, which is flooding here and there all around the sample. And whatever the slurry is coming out, that you can see it is this is the outlet. So the slurry is being circulated through this piping, and the jet, and the slurry is coming out of the jet. After directing over the surface, the slurry is coming out of this outlet, and then again. So this process is continued, obviously. So depending upon the duration for which slurry jet will be directed over the surface, that will be deciding the kind of the material that will be removed due to the slurry erosion. So we can determine like the amount of the material lost from the surface in terms of the weight or in terms of the depth which has been lost per unit time, like that. Also we can, so there are different ways to express the slurry erosion rate. So now this is the sample you can see which has been subjected to the slurry erosion test, and we can take the weight of the sample after the test to determine like the kind of amount which has lost from the surface. So depending upon the difference in the weight loss, final weight, initial weight minus final weight, that will give us the weight loss due to the erosion, and that is what you can help in determining the erosion rate by dividing the duration for which the slurry test was conducted. That's all. Thank you.